So as we can see in this problem, since we have only 5 unknowns but 6 equations, we should see if the sixth equation is satisfied or not. So as you can see, if we go back to our equations, the 3 equilibrium equation of forces and the 3 equilibrium equation of moments, okay? If you solve for them, you need only 5 of these equations. What do we do with the 6 ones? Why we should look at the 6th equation, okay? Because we have that to ensure equilibrium, the 6 equations should be satisfied. But the 5 equations, the first 5 will give me all my unknowns. So the 6th equation will be used to verification. I should verify if the 6th equation is satisfied or not. If it's satisfied, I say it's fine. I have equilibrium in this problem. If it's not satisfied, I will say it's impossible to have equilibrium for this type of loading. Okay, so it's very similar to the example I give you for the rollers. For the rollers, if you put Y load, you can have equilibrium. But if you put X loading, when you write sum of X equals 0, it will give you impossible. Because let's say you put a force in X of 10 Newton, and you don't have any force that can resist to it. So if you put sum of X equals 0, you will get 10 equals to 0, which is impossible. Similarly here, we calculated all our forces using the first 5 equations. Now, once done, we should verify that the 6th relation is satisfied. So if you look at your equations here, okay, the 6th equation will be that TDE should be equal to TBD should be equal to TBE. And this is satisfied. Why? Because when we did the calculation, we got that TD is equal to 200 and TE is equal to 200. So as you can see here, this equation will be like a repetition of the result I already obtained. It will give me that TDE equal TE, and this is verified. Okay, from the other equations, this is verified. So in this example, equilibrium is possible. But for example, if I got TD equals 300 and TE equal 200, then this equation will not be satisfied. And what you will say in this case, you will say it's impossible to have equilibrium for this type of load. Okay, any question for this problem? So as you can see here, once you know how to calculate the moment, the equilibrium is very simple. And the equilibrium is just application of sum of forces equals 0 and sum of moment equals 0. So if you understand well the previous chapter, how to calculate the moment of a force, and of course, if you use from chapter of exam 1, you should know the unit vectors, you should know how to express a force, then it will be a direct application. Just you put your forces, you say sum of forces equals 0, sum of moments equals 0, and you solve your equations. Okay, so let us do the final problem. In this problem, the cable can be subjected to a maximum tension of 300 lb. Determine the maximum force which may be applied to the plate. Compute the XYZ components of the reaction at the hinge A for this load. So here it's a hinge, like the door, like the reaction of the door. We said that for this type of reaction, we can only do what? We can only rotate about Y. Okay? Since we can only rotate about Y, we have 5 reactions here. We have Fy, because we cannot translate. We have Fz, and we have Fx. But also don't forget to put the reaction of moments. Okay, so we have a couple moment along X, a couple moment along Z, but only we don't have a couple moment along Y, because we can rotate about Y only. Okay, so I will put, I have a moment about Z. Just 1 minute, I want to put the charger. Okay, so we have a moment about Z and we have a moment about X. Okay, so we have 5 reactions at my hinge. Okay, I have, as you can see in this figure, AX, AY, AZ, and MAX, MAZ. Now, the second step is to write the equilibrium equations. Okay, and of course you have the tension in the cable. So here they told you that we want to design based on the maximum tension. The maximum tension in the cable is 300. So I will put here 300. Okay, and I want to find what is the maximum force F, which will lead to the maximum tension. So here I have F as unknown. Okay, and I have in this problem 6 unknowns, so I can solve by writing the 6 equations of equilibrium. So let us start. The first relation is sum of x equals to 0. If you look at your forces, the only force along x in this problem is AX. So you deduce that AX equal to 0. So it's relatively a simple problem because the load is only along Y. The same along Z. If you do sum of forces, the same along Y. If you do sum of forces along Y, you have only AY. Okay, so you deduce that AY is equal to 0. Now, your third equation is sum of forces along Z. Along Z, you have 3 forces. You have plus AZ minus F plus TBC. But because you know the value of TBC, you directly replace since it's equal to 300. So you can say that along Z, the equation is 300 minus F plus AZ equals to 0. Okay? Now, these are the first 3 equations they are not enough, so I need to move to the sum of moments relations. Now, in this problem, if you want, for example, no need to use vectorial product, because in this problem, the forces are very simple. Okay, so you can calculate easily the moments. To start with, if we do sum of moment about x-axis, okay? This is our x-axis. So let me clear everything now. Let us start with moment about x. As you can see first, don't forget always, if I'm doing sum of moment, don't forget the couples, okay? When you do sum of moment about x, you should include what? The couple moment, MAX first, okay? So here, if you want, they choose MAX already in the negative direction. It's an assumption. This is why they considered minus MAX. But it's up to you. You can put it positive. You can put it like this. If you put your arrow like this is a positive. So if you do the right hand rule, it's positive. You can stick to plus MAX, and when you solve, you will know if it is positive or negative. Okay, but because they considered the positive direction along minus x, this is why they put here minus MAX. Now, we don't have any other couple in x. We will move to a moment of forces about x. But as you can see, the tension force, this is your tension force, is passing by the x-axis. So it cannot produce a moment about it. For F force, it can produce a moment. And we should multiply F by which distance? We should take the perpendicular from F to x-axis, okay, which is the coordinate along y, which is 2. Okay, we should multiply by 2. So the magnitude is F times 2. What about the direction? Take your right hand, okay, put your 4 fingers along F and try to rotate. So I will draw it for you. You put your 4 fingers like this, and your hand is facing X. Then if you take your thumb will point in the negative X direction. This is why it's a negative moment. So minus F times 2. Okay? You still need to see if I have other moments for forces. Let us look at the reaction at A. For AY, no moment Y, because it's passing by x-axis. And of course, for AX, no moment, because it's parallel to x-axis. So I only still have moment of AZ. Okay? To find the moment of AZ about x-axis, first to know the direction, I use the right hand rule. 4 fingers along my force. My thumb will point in which direction? If you try to do it, your thumb will point in this direction. So you have a positive moment. Plus AZ times which distance? Look, this is AZ is applied at point A. So you should take the distance from here to here, okay, which is 1 plus 2, which is 3. So plus AZ times 3 equals to 0. This is sum of moment about x. Let us move to sum of moments about y. About y, what do we have? We don't have a couple moment about y, okay? We have the moment of TBC and the moment of F only, because AX, AY, and AZ, the 3 forces here pass by y-axis, so no moment. So I'm left with the moment of F and the moment of TBC. Now, to know the moment of F, I do the right hand rule. If I do the right hand rule to find the direction, okay, this is my right hand. It's facing y-axis. If I take my thumb, it will point like this. It will point towards positive y. So for F, it's a positive moment plus F times, I should multiply by the distance to the axis. This is the distance to the axis, which is 3. This is why it's plus F times 3. And for TBC, for the direction, it will be opposite, because look, F is down, T is up, and both are from one side of y-axis. So if I do here the right hand rule, if I take my right hand, I undo this, my thumb will point in the negative direction. So it's minus TBC, which is 300, times the distance to y, which is this one. It's given to be 9 feet. So from sum of moment about y equals to 0, you can get the value of F, because look, your only unknown here is F. So from sum of moment about y, I can get what is F. Okay, and of course, once I get F, I can replace back here to get what? To get AZ. Now, if I do sum of moment about Z, this is the last step. Sum of moment about Z, I have that, as you can see, for AY, it's passing by Z, no moment. For AZ, it's parallel to Z, no moment. Okay, so I still have only AX. AX is producing a moment about Z, and if I do the right hand rule, I put my 4 fingers along X, okay? My thumb will point, so my thumb will point in the negative, so my fingers are facing Z, okay? My thumb will point along negative Z direction. So it's a negative moment. This is why I do minus AX times which distance? The distance to Z is 1 plus 2, it's 3, okay? So minus AX times 3. And don't forget to add what? To add the couple moment in Z, which is plus MAZ, okay? Equals to 0. But since AX is 0, because from sum of X equals 0, you have AX equals to 0, you deduce that MAZ is 0, okay? And now, once you find F and AZ, you can replace an equation sum of X, sum of moment about X equals 0, so you can get the value of MAM, okay? In this way, we have solved to all of our 6 unknowns by writing the 6 equilibrium equations. And we are done with chapter equilibrium of a rigid body, okay? So please, during this weekend, try to start doing the problems on moment of forces and equilibrium of a rigid body. And it's up to you. If you prefer that we keep the revision of problems just before the exam, we can start a new chapter now, next time. And after, before the exam, we do review sessions with the review problem. Or if you prefer to start directly with the problems, it's up to you. So I don't mind. So what do you prefer to do next time? To start problems on these chapters, or do you want some time to study?
And I prefer to start the review problems.
Okay. So we will discuss this on the group. Okay. And
Yes, okay.
we will see what to do next time. Okay. Good.
Okay.
Have a nice weekend. Bye.
Thank you, doctor.
Thank you. You too, doctor.
Thank you, doctor. You too.
Bye bye.